Welcome everyone to the keynote AI for Net Zero Energy. This presentation is part of the AI for Net Zero track of the 2021 AI for Climate Global Forum. My name is Regina Cervera, Global Forum Coordinator, and it's a pleasure to be here with you today. I would like to welcome our special guest, Peter Cloddenbrock, who will share with us some really interesting facts on the challenges and opportunities of leveraging AI systems for net zero goals. I would like to tell you more about our expert guest. Peter Cloddenbrock's work focuses on the intersection of emerging technology and climate change. Pete is a co-founder of the Center for AI and Climate, where he supports the application of data science and AI to climate-related challenges. He is CEO of Radiance International, an independent climate consultancy where he works with some of the largest tech companies in the world on corporate climate strategy and delivery. He has in-depth expertise in climate policy and government relations, having worked with the UK government on national and international climate policy. Pete, thank you so much for joining us today. The microphone is all yours.
Thank you very much, and thank you for having me. It's great to be here, and I'm going to talk for about 20 minutes about how AI can support the transition to net zero, and in particular focus a bit on the energy and electricity sector where it can have a lot of impact. So as a bit of background, as Regina mentioned, I'm Pete Cloddenbrock, and I'm one of the co-founders of the Center for AI and Climate, which is an organization that brings together data scientists and experts from the energy and climate space to support the application of data science and machine learning to climate-related challenges. So our team is made up of a range of people working in the private sector, working in academia, working in government and the third sector, all looking to support the application of AI for climate change. So we've got people from DeepMind, people working on energy, people working on wider industry use cases, a whole range of different people involved in the organization. The purpose for the Center for AI and Climate Change is that it's a cross-functional facilitator and incubator that aims to connect capabilities across technology, policy, and business to accelerate the application of AI to solve climate challenges. And the idea is really to provide end-to-end support for the AI for climate ecosystem. The reason that we work on this problem is that we see a wide range of potential opportunities to apply data science and AI to support the transition to net zero and to help countries adapt to climate change. So here on this slide, we've got a range of examples for how AI can support this transition. So in the energy space, there are a whole range of opportunities from individual asset optimization to electricity dispatch and scheduling to optimizing forecasts of demand and renewable energy supply. In the industry and building space, there are a whole range of interesting examples around optimizing existing industrial processes or supporting the development of new industrial processes and the design thereof. In the transport space, again, really exciting opportunities around analyzing traffic patterns to help reduce congestion, freight and delivery optimization, vehicle design optimization, optimizing for EVs as they come online. Again, really interesting applications. Forests and agriculture is a huge area of opportunity. We're seeing vast amounts of satellite data come online, which is much higher resolution and more affordable, and that's being coupled with machine learning to do a range of really exciting opportunities, things like identifying illegal logging, forest carbon accounting, optimizing afforestation, and things like that. It's not just about mitigating though. We can use AI to help adapt to climate change that's unavoidable. So whether it's looking at food security or localized crop yield assessments or forecasting and tracking of extreme events, again, there are a whole range of opportunities to use data science and AI in that space. And beyond adapting and mitigating to climate change, actually understanding the science of climate change, there are really interesting opportunities. We're seeing AI already being deployed to help emissions monitoring, to help improve the accuracy of climate models and understand the tipping points of climate change and when they can come into effect. That said, despite all of these opportunities, deploying AI to address climate change is not without its challenges. There are a whole range of issues that make it harder to apply than perhaps it should be. So some of these challenges are around data. I think a lot is made around data access, but we also need to focus around data collection, data discovery, data quality and data standards, all of which need radical improvements to support the application. Because the average machine learning project takes about 80% of the time involves just cleaning and labeling data sets, not developing the AI algorithms themselves. But data on its own isn't enough. Often the sectors that we care about when it comes to climate change are some of the most heavily regulated, whether it's energy or transport or land use. And in those sectors, the policy frameworks and market structures that define the incentives within those spaces were designed in an analog era and have yet to be updated for a digital, let alone an AI age. So all of that will need to be changed and adapted to support the application. Funding is also a massive issue. So we talk to a lot of venture capitalists in the space who understand the potential value that AI has to offer in this space and think it's really exciting, but are wary about investing because of the challenges of supporting applications in sectors that are heavily regulated. So you find funding in AI for climate change is dwarfed by funding for AI and fintech and healthcare and ad tech and other spaces. There's some really interesting research, fundamental research from academic institutions, but it's at the moment fairly nascent and patchy, and much better coordination is needed, and a greater focus is needed to build the talent pipeline for specific areas where AI for climate can be applied. And specifically, that talent needs to be bringing together both AI data science talent together with very specific industry expertise on specific sectors, whether it's the transport sector or land use. But it's the combination of that specific sectoral knowledge plus data science knowledge, which is really powerful and in real need. Fifthly, startup system integration. So this is one of the challenges that we find again in sectors that are perhaps most important to climate change, where you've got long-standing incumbents or monopoly situations where it's really hard sometimes for startups to get a foothold. And in those particular instances, there's a real case for better system integration and a way for startups and innovators to find a pathway to scale and to market. At the moment needs a lot of support. And finally, one of the biggest challenges to work in this space is perhaps the soft challenge, but perhaps one of the biggest is that often you have silos of knowledge in this space. So you have AI experts who would love to get involved in working on climate change, but don't really know how or what problems are most salient and important to work on, and vice versa. You have people working in the climate space who would be very interested in adopting AI solutions, but don't really know where to start and what kinds of problems AI can help solve. So bringing together these knowledge silos is going to be really important. So what we've been talking to policymakers about and a whole range of people about is the need for end-to-end ecosystem support to really address all of those challenges that I've just talked about and to unlock the solutions that I identified. So this begins really early on in terms of building a talent pipeline and targeting doctoral training and funding on the basis of industry feedback. That's really important. We talked about research coordination, and that needs to be done through building coordinated research coalitions with industry. So identifying the challenges that industry are facing and identifying research coalitions to work around those. Then we need to have much better awareness about what the key opportunities are. So this is about building coalitions, identifying the gaps, bringing tech delegations to countries where there's not enough capacity in them, and working together across countries to make the opportunities come to the fore. And then next is around data and access and quality. We talked about that. So making sure that data discovery is easy. So making it really easy for data scientists to find the data they need to help address particular challenges. And on the back of that, helping to coordinate the development of specific public interest models. So for example, in the energy space, there's a real need for digital twins. Making sure that governments have put funding towards things like that is really important. But then we need a whole ecosystem of innovators building around this space. And that's going to start by providing some initial support for early stage startup projects, just to help develop proof of concepts to get things off the ground. And that may come in the form of offering machine learning challenges or key challenge sprints to help form those initial teams and ideas. But that can then be developed further by supporting promising projects with some kind of further funding, whether it's semi-commercial seed equity funding or something like that, to help those projects actually gain commercial traction. And finally, we need policy work to expand the markets that are available at the moment and to facilitate projects. So we need this end-to-end ecosystem of support, because if we address any one of these challenges on their own, projects won't go through the system. We need all of them to be addressed holistically. So what are we doing in terms of the Centre for AI and Climate Change? We're working on a few high-level flagship programs. So we're working across key sectors that we think there's particularly high impact examples of where AI can make a real difference. So one of these is around AI for renewables dominant grids. So as we get to higher percentages of renewables on electricity grids, operators will increasingly need to use AI to manage and optimize the operation of an ever increasing number of assets on their systems. Secondly, AI for forests. The Centre will bring together a coalition of organizations to optimize forest commodity supply chain tracking and apply data science and machine learning to enhance forest assessments. AI for food security is the third. So using AI and satellite data, the Centre will develop a platform to showcase areas at risk of food insecurity. AI for new fuels is a really critical one. New fuels are needed across many energy-intensive industries and transport modes where they don't currently exist, and the Centre is going to help coordinate a research program focused on the application of AI to help accelerate the development of new fuels for use in energy-intensive industries and for transport modes which need new fuels where electrification isn't necessarily an option. Fifthly, project tipping points. So this is around identifying existing data sources for climate tipping points, identifying where data needs improving, and applying machine learning to radically improve our understanding of the status of climate tipping points, whether or not it's the damage to the Amazon rainforest or methane release from the permafrost in the Arctic. And finally, data for climate. So this is a bit of a cross-cutting theme, but one of the biggest challenges for applying ML and machine learning is easy access to clean, labeled, standardized data. And this particular platform that we work on will act as a portal for data that can support the transition in key sectors that we care about. So I'm going to focus a bit on AI for net zero electricity because the electricity sector is one of the sectors where we think AI has the most potential to unlock unlock the transition. So I'm going to talk about a few examples of where we're already seeing AI being used in the electricity sector. So one is around forecasting. As we move towards scenarios where we have much higher percentages of renewable energy on electricity grids, we're going to need radically better forecasts of both electricity demand and renewable energy supply to enable them both to be matched in real time, despite the fluctuating demands of both. So we've got examples such as Open Climate Fix, which is working with National Grid in the UK to use machine learning to improve the forecasts of solar generation. And they've also doubled the accuracy of demand forecasts for National Grid as well. So that's already being applied in the National Grid control room. Secondly, balancing optimization. So again, as we get greater amounts of renewable energy on grids, this will require large amounts of flexible balancing capacity, whether or not it's battery storage or demand-side response. Optimizing the use of this balancing capacity will be critical in minimizing the costs of net zero grids. One example here is from Habitat Energy, which optimizes grid-scale batteries. And it does so by taking data on battery chemistry and data on electricity markets and using machine learning to develop optimal trading strategies for battery assets. So they play both into the wholesale markets in the UK as well as the balancing markets, and they develop optimized trading strategies using AI. It's a really interesting piece of work. And thirdly, renewable energy optimization. So combining machine learning with improved wind energy forecasting with optimized trading strategies can really make wind assets more valuable to the grid and hence more valuable to their operators as well. So one example here is that DeepMind, based in the UK, is using machine learning to boost the value of wind assets owned by Google by about 20%. So again, a really significant financial benefit for renewable energy asset owners and operators. But these are just a few examples, and I think what we want to try and show is that AI is not going to be used in a few different examples. It's going to flow into all aspects of decision making and management within sectors such as the electricity sector. So to paint a bit of a picture of the vision that we have for the electricity sector, one of the key issues that I've just mentioned is that is how we can balancing capacity. So again, whether it's battery storage or demand side response, how can that be best managed and delivered without compromising grid function and with minimal cost to the consumer? And the way we see this playing out is that we think all buyers and sellers on the electricity markets that are able to offer balancing services will need to use AI optimized trading algorithms, AI optimized forecasting algorithms, and in some instances, AI optimized asset planning to help optimize their decision making. So generators will use AI to optimize when they sell electricity onto the grid. Suppliers will be buying and will determine buying and consumer pricing strategies using AI, and flexibility providers will use AI to optimize their buying and selling. So we're seeing really interesting. I think what we're imagining is AI focused perhaps specifically on the market applications where you've got decision making being done in very high resolution ways, and that's going to be pervasive throughout the electricity market. But in order for that to happen, there's a lot of data that's needed. So AI optimized trading algorithms will in turn need good data on any assets that they are offering services against. So if you're optimizing services against a battery, for example, you'll need really good data on the chemistry of that battery. You also need really good data on the wider market. So you'll need really good data on the electricity grid into which you're playing, on the constraints in that system, when and where they occur, and so on. And that data at the moment is not available. So this is going to require a fairly radical shift from how data is currently made available by electricity network companies, particularly whether it's transmission or distribution networks, and to open up that data. So having a presumptionness of openness of that data is going to be critical, as well as thinking about how you can better improve data sharing protocols and standards across the system as well. This involves a selection of key players, and we've just highlighted a few here in this slide, but there are a whole range more that need to be addressed. But I'm just going to focus a bit on grid companies, innovators, and policy makers and regulators. So grid companies, we have transmission and distribution network operators, and they play a really critical role in the transition to net zero. The challenge that they have is that they tend to be very low risk businesses. So the investors that put money in want a stable return on their investment with low risk. But the problem is, in order to get to net zero, they're going to have to innovate, which can be risky. That's going to require a pretty drastic change in their approach to innovation and risk taking. And grid companies are going to have to rapidly build both their own digital capabilities, but also seek to develop innovations, ecosystems around themselves to support the development of AI for energy solutions. So bringing in innovators externally. Innovators themselves, I think, sometimes struggle to work in the electricity sector. It's complex. There are a wide range of regulations that make it harder than it should be to get involved. And success can rest on agreeing a handful of contracts with a small number of grid companies, which makes it a really risky space. To really add value, machine learning experts need to specialize in sectors such as energy to understand the systems in order to deploy useful digital solutions. So again, this speaks to the real need to have this combination of a deep understanding of both data science plus a deep understanding of the sector that you want to make a difference in. And thirdly, policymakers and regulators. So policymakers in many countries are currently considering electricity market changes to support the transition to net zero. But too often what we see is these processes are not involving digital experts who could advise on how to ensure these processes of updating regulations can support digital innovation. And that needs to change. All of those processes need to involve digital experts who can make sure that they're designed in a way that's future-proofed, that enables these emerging technologies to maximize potential in the context of the electricity sector. So I've had a very quick run through of some of the exciting opportunities that AI offers across the piece when it comes to climate change. I've talked a bit about the barriers that currently make it harder than it should be to do so, to apply these solutions. We've dived into a bit of a conversation around the ecosystem that we need to build in this space. And then we've talked specifically about the electricity sector and how we imagine it evolving over the coming years, both in terms of what role the different actors in the system need to play, and some of the challenges for them to do so. And with that, I'm going to bring my presentation to an end, and happy to answer any questions as and when that's possible. Thank you very much. Was that okay? Was it a bit shorter than what I
No,
expected? I
thank
think I
you.
ran through that a bit quicker.
No, thank you, Peter. That was amazing. That was really valuable information, and I totally agree that it is. I think it's impressive how much work could be done if through policy mechanisms we could make sure that great companies, innovators, and governments, you were saying, can access and have access to this clean, accurate data, right? To support this energetic transition and in electricity markets towards net zero. And I was amazed how you also talked about, well, the role of forests, and how protecting forests can also help us achieve these goals, and all the implications that this could also have on food security around the world. So like you said, it's all connected, and we need the participation of policymakers, companies, innovators, and people like you. You're doing this awesome work at Radiance and at Center for AI and Climate. So yes, it is impressive how much could be done if this ecosystem, like you were saying, works together for this goal, right? Sometimes it's hard to bring together all these actors to the same table to discuss. And we're seeing now in the COP, we have people like you, we have global leaders talking about reducing 30% of methane emissions and so. But yes, we need to see action right now. We need to see them come together, like you were saying. So thank you. This was really enriching and amazing. And to all of you who are still watching us, stay with us for the next presentation of the AI from Net Zero track, and have a wonderful day.